We are going to talk about adding and subtracting radical expressions in this lesson. Now, what is 10 square root 8 plus 2 square root 18? Since the radicals are different, we can't add the coefficient, that is the numbers in front of the roots. But the radicals, that is the roots, can be simplified in this case. So square root of 8 can be simplified and square root of 18 can be simplified. This gives us 10 square root 4 times 2 plus 2 square root 9 times 2. We spread the roots across the factors. Plus 2 square root 9 times square root 2. 10 times 2 times square root of 2 plus 2 times 3 times square root of 2. So square root of 4 is simplified to 2 and square root of 9 is simplified to 3. So 10 times 2 is 20. You add a square root there, square root 2, plus 2 times 3 is 6. You add a square root there. The square root of 2 is the same because it can't be simplified any further. Now that the radicals are the same, we can easily add the numbers in front of the roots, which gives us 20 plus 6, which is 26. And then we put the square root there, square root 2. So 26 square root 2 is the answer. If we had a question like 10 square root 8 plus 2 square root 79. 10 square root 8 can be simplified, but 2 square root 79 can't be simplified. So let's remember that in my previous question, we got 10 square root 8 to be 20 square root 2. So we're just going to write it there. 20 square root 2 plus 2 square root 79. So we can see the radicals are different. Square root of 2, square root of 79. They aren't the same. So we can't say 20 square root 2 plus 2 square root 79 is 22 square root 2 or 22 square root 79. We just can't say. So that is why in addition and subtraction of surds, we have to make sure the radicals, that is, the roots, are the same. So a question like 7 square root 9 minus 3 square root 3. So it gives us 7 times, so square root of 9 is simplified to 3, minus 3 square root 3. So 7 times 3 is 21, minus 3 square root 3. And can this be simplified further? No, because the first expression, 21, doesn't have any radical to talk of having equal radicals with negative 3. So this cannot be simplified any further. And here is your answer. So having heard my explanation, feel free to pause the video to solve my question. 4 square root 5 minus square root of 5 plus 7 square root 45. So this and this term and this term are like terms. They have same radical. That means they can be easily subtracted. Now let's remember that there is a 1 here. So 4 minus 1 gives us 3 square root 5 plus 7 square root 45. So now in this case, square root of 45 can be simplified to have a root of 5. So 3 square root 5 plus 7 square root 9 times 5. So 3 square root 5 plus 7 times square root of 9 times square root of 5. 3 square root 5 plus 7 times 3, square root of 9 is simplified to 3, times square root of 5. It remains the same. 3 square root 5 plus 7 times 3 is 21, square root 5. Now that they have same radical, that is equal radicals, we can easily add the coefficients, that is 3 and 21. So 3 plus 21 gives us 24 square root 5. Let's try an example with cubic roots. You can feel free to pause this video if you want to try your hands on this question. 4 cube root 8 minus cube root 27 plus 7 square root 4. This gives us 4. So here we want to find a number that when multiplied thrice, that is 3 times, gives us 8. And that number is 2 minus the same with this. A number when multiplied 3 times gives us 27. And that number is 3 plus 7 square root 4. So this is a square root. So 7 times 2. Square root of 4 is the same as 2. So 4 times 2 is 8. So 8 minus 3 plus 7 times 2 is 14. So 8 minus 3, 5 plus 14, 19.